The park's radio telescope scanned the Milky Way for decades, its dish turning like a slow, silent eye. Data streamed from its receivers in paper printouts and magnetic reels. Then in 2007, a young astronomer named Duncan Lorimer pored over a decade-old archive. A single, impossible spike jumped off the page, a millisecond-long radio flash, buried deep in data recorded from 2001. No star, no pulsar, no known phenomenon could create such a burst. Imagine the energy of a billion suns concentrated into a single, vanishing instant. The sun's output for asterisk, one full day condensed into a heartbeat. No other signal matched it. For years, astronomers searched the sky looking for a repeat. The signal came from a point far beyond our galaxy, a dot in the void. Each burst carried energy rivaling a supernova's output, yet vanished faster than a camera flash. Imagine the entire power grid of the United States flickering to life, then gone before you could count to two. The universe had sent a message, but no sender was visible. The Lorimer burst remained a lonely, unexplained echo. Then, in April 2020, the quiet Milky Way suddenly flared. A magnetar named SGR 1935 plus 2154, a collapsed stellar core with a magnetic field a billion times Earth's strength, erupted. Its surface cracked like glass under unimaginable pressure. The burst it emitted was identical to distant FRBs recorded for years. No other source could mimic it. Astronomers confirmed it. Magnetars asterisk could asterisk produce these flashes. For the first time, a known cosmic engine powered the mystery. Hundreds of FRBs are now cataloged, mostly distant and one-time events. The CHIME telescope detects them routinely, each a fleeting data point. Yet the magnetar proof only solved part of the case. Most FRBs still originate from unknown mechanisms, possibly different cosmic cataclysms. Imagine a single grain of sand on a coastline stretching to the horizon, each grain a burst, lost in the endless night. The park's data was the first clue. The magnetar provided a suspect. But the true source, the asterisk Y, remains hidden in the deep black. The search continues. CHIME scans the sky like a hawk spotting prey in the dead of night. Its radio dishes catch hundreds of FRB flashes each month, each lasting less than a millisecond. Park's telescope data from 2001, analyzed years later, revealed the first known FRB, a brief, impossible flash buried in the noise. Now, CHIME detects one every day, a relentless pulse from the cosmic deep. Imagine the energy. One FRB unleashes more power than our sun emits in asterisk 3 full days asterisk, all in a blink. Most vanish forever, leaving only a faint echo in the data. FRB 121102 repeats. Its bursts arrive like a heartbeat, clustered over time. Astronomers traced it to a dwarf galaxy 3 billion light-years away, pinpointed by radio telescopes. This wasn't a one-time explosion. It's a persistent signal from a stable source. A magnetar could explain it, but why does this one repeat while others vanish into silence? The pattern suggests a different engine. Perhaps a young neutron star still shedding its magnetic grip, pulsing steadily like a lighthouse. The magnetar SGR 1935 plus 2154's 2020 flare was a perfect match. Its magnetic field, a billion times stronger than Earth's, cracked its surface like thin ice under crushing weight. The burst recorded was identical to distant FRBs. No other source could replicate it. Astronomers held the smoking gun. But magnetars alone can't explain all FRBs. Some burst only once, never to be seen again, hinting at catastrophic events like neutron star collisions or a collapsing star's final scream. Other theories linger. Pulsar glitches are too weak. Neutron star mergers emit gravitational waves, not these radio flashes. Cosmic strings, a theoretical kink in spacetime, could vibrate with the needed energy, but no evidence exists. Imagine standing on a grain of sand on a beach stretching to the edge of the observable universe. The theory might be true, but we have no lens to see it yet. CHIME keeps flashing. The repeating FRBs whisper of ongoing processes. The one-time burst scream of sudden, final violence. The magnetar solved one chapter. The rest remains a black page, waiting for the next clue to flicker across the sky. The magnetar SGR 1935 plus 2154 solved one puzzle. Its 2020 flare, recorded by radio telescopes, matched the exact millisecond burst profile of distant FRBs. Its magnetic field, 1 billion times Earth's strength, cracked the neutron star's crust like thin ice under crushing weight. The burst's energy signature was identical. No other source could mimic it. Yet not all FRBs repeat. Isolated flashes vanish without trace, leaving no echo. A single catastrophic event, like a neutron star tearing itself apart, explains this silence. No magnetar pulse could replicate that final, violent scream. Pulsar glitches are too faint. They produce mere whispers compared to FRB's roars. 1 millisecond flash releases energy equal to the sun's total output over days. Imagine the entire sun's fire compressed into a single, perfect football field. Pulsars barely flicker in that scale. The energy gap is a chasm. No known pulsar mechanism generates such raw power. Neutron star collisions create gravitational waves first. LIGO detects those ripples clearly, but no FRB precedes the wave signal from a merger. If collisions caused FRBs, we'd see both signals together. We don't. The radio flash is missing. A single, violent collision should leave both a cosmic scream and a gravitational whisper. The evidence remains silent. Cosmic strings, a kink in space-time, could theoretically release such energy, but no gravitational wave signature matches. They remain a beautiful idea without proof. Imagine standing on a single grain of sand on Earth's shore, seen from orbit. The theory might fit, but we lack the lens to see it. CHIME's skywide survey continues, catching hundreds of new FRBs daily. Repeating bursts with pinpoint locations could map to magnetars. A single non-repeating burst caught simultaneously with a gravitational wave would prove collisions. The next flash could be the key. What final scream will it carry?